Now we've talked about processing a few times in this module, and we're almost ready to talk about it in more depth. But before we do, we need to understand something about analysis services storage modes, because the type of storage that we use will affect exactly what happens during processing. First, we have MOLAP. MOLAP stands for multidimensional OLAP, and it's the default storage method, and it's the one that's generally recommended. It provides the fastest query performance, and it provides the best compression of data. With MOLAP storage, we have both data and aggregations in something called the MOLAP cache. Let's take a look at how that works. Here we have a diagram that shows our relational source system on the left, and then we have the analysis server that contains two objects. One object is the UDM, and that stands for Unified Dimensional Model. You can think of that as the collection of XML files that get deployed to the server. Those files contain the instructions that tell analysis services what information to store in the cache. Then the MOLAP cache is the physical storage of our cube data and dimension data. Now when users query a cube, the storage mode is irrelevant, so we can make changes to the storage mode without having to change anything in our client tools. But what happens during processing and what happens during querying does depend upon storage mode. So let's take a look at that now. When we instruct the analysis server to process a database, we're telling it to read the information from the UDM, query the relational system, and fill the MOLAP cache with both data and the aggregations if we've designed them in the cube. Remember from a separate module in this course that we can think about aggregations as being summary tables that are stored in addition to the detailed data that we get from our fact tables. Then when the user queries the cube, they're either writing MDX directly or using a tool that generates MDX that queries the cube, and then the analysis server determines whether to respond to that query from aggregations or from the detailed data. Then we have HOLAP. HOLAP stands for Hybrid OLAP. With Hybrid OLAP, only the aggregations get stored in cache. So when we do processing, the UDM again provides the instructions to the analysis server to get the data from the relational system, but only aggregations are calculated and stored on the server. When the MDX comes from the user, Analysis Services determines whether it can answer the question from aggregations or whether it needs to retrieve detailed data from the relational system. So it interprets the MDX that's coming from the client tool into SQL statements, sends that statement to the relational system, and then returns the results along with any results derived from the aggregations, and packages it all together for the user. This option is really only useful if most of the queries can be answered with aggregations. If information has to come from the detailed data back in the relational source, that query is going to perform very slowly as compared to MOLAP storage. Our third option is ROLAP. ROLAP stands for Relational OLAP, and in this case, all of our data, both the detailed data as well as the aggregations, are stored in the relational system. So when processing occurs, essentially all we're doing is building up pointers back to the relational system. From the end user perspective, they're querying a cube and they won't be able to see that the queries are actually passing through to the relational system. They may notice a difference in query performance, however. So whether the query can be answered with aggregations or requires detailed data, all queries are redirected to the relational system. Now, even though ROLAP queries tend to be slower than MOLAP queries, the benefit is that relational systems tend to have more current data available for users. So we have a trade-off of having fresh data in ROLAP as compared to fast data in MOLAP.